Welcome to the DIY Honda Garage channel. DTC P24BF indicates a problem with the canister changeover valve control circuit, triggered by high voltage. This occurs within the Honda CR-V 2023 and beyond, specifically when the powertrain control module, PCM, detects an anomaly in the electrical signal to the canister changeover valve. The canister changeover valve plays a crucial role in controlling fuel vapors and is integral to the vehicle's evaporative emission control system. When the PCM outputs a closed signal but receives an open signal instead, it indicates a malfunction. This results in the DTC being stored for further inspection. A proper understanding of these signals is crucial for accurate diagnostics and repair. The error associated with DTC P24BF involves the canister changeover valve, a crucial component in the evaporative emission control system located within the evap leak check module. This valve regulates fuel vapors, ensuring they are captured and directed back into the fuel tank or the engine. The PCM, or powertrain control module, is responsible for controlling the valve based on various engine conditions. When the PCM attempts to close the valve, but receives an indication that it is still open, this discrepancy is interpreted as an error condition. The canister changeover valve's location is essential to note, as it is integrated with the evap leak check module, making it relatively inaccessible without disassembly. Understanding how these components interact through electrical signals is key to diagnosing the issue accurately. Several potential causes can lead to the DTC P24BF being triggered. One major reason is shorted wire conditions, which could indicate physical damage to the wiring harness that connects the canister changeover valve to the PCM. A faulty evap leak check module could also be responsible for failing to relay proper signals to the PCM, which thereby thinks the valve is malfunctioning. Another possibility includes a PCM malfunction, meaning the control unit itself is providing inaccurate commands or misreading the valve status. Corroded connectors or poor electrical grounding may also disrupt the flow of signals, contributing to this diagnostic trouble code. Understanding these causes helps technicians narrow down the troubleshooting process efficiently. Specific symptoms can arise from the issues associated with DTC P24BF. Primarily, drivers may notice a check engine light illuminating on the dashboard, signaling that something is wrong with the emission control system. Additionally, issues such as poor fuel efficiency might surface, as improper control of fuel vapors can lead to increased fuel consumption. Likewise, emissions levels may rise, potentially leading to environmental compliance issues during emissions tests. Drivers may also experience rough engine idle, as the valve's improper functioning might disrupt the optimal air-fuel mixture, leading to erratic engine performance. Recognizing these symptoms early can assist in timely diagnostics and repairs, ultimately ensuring the vehicle operates smoothly and within regulations. The first step in troubleshooting DTC P24BF involves turning the vehicle's ignition to the on mode, ensuring that the electrical systems are activated without starting the engine. Next, you should run the HDS, or Honda Diagnostic System, specifically performing the evap leak check module test. This diagnostic will provide real-time information on the system's performance. It's crucial to observe the test results closely. If the output is not okay, it indicates that the failure condition has been duplicated and further investigation is warranted. Note that this initial step is essential for identifying whether the issue is ongoing or has been resolved, giving technicians a clearer understanding of the remaining diagnostic path. The second step entails inspecting the external circuit associated with the canister changeover valve. One of the primary focuses should be on checking for a shorted wire in the circuit. which could render the valve inoperable or create false data feedback to the PCM. According to the inspection description, careful consideration is needed when examining wiring and connectors for any visible damage or signs of wear. Performing this inspection meticulously can reveal underlying problems that may not be immediately apparent. Documenting the inspection results is crucial, as this will help track the troubleshooting steps taken and identify trends or repetitive issues over time. In the third troubleshooting step, the focus shifts to inspecting the evap leak check module itself. Since there isn't a direct testing method for this component, the recommended approach is to replace it temporarily with a known good component. This method helps to verify whether the original module is functioning correctly. The core of this diagnostic process is to reproduce the same failure conditions to see if the symptoms persist. If, after replacing the evap leak check module, the failure is replicated, the issue likely lies elsewhere, perhaps in related components such as wiring or connectors. Conversely, if the DTC clears and the symptoms resolve, it's conclusive that the original evap leak check module was faulty. The fourth step centers on the PCM itself, particularly if other inspection items have shown normal conditions. At this stage, it's critical to evaluate the functionality of the PCM in relation to the canister changeover valve and the entire emission control system. This involves checking if the PCM is sending and receiving the correct signals as expected. If all previous inspections indicate proper performance and the DTC persists, the PCM is likely the root cause of the issue. It's essential also to document these findings carefully, since this information can be vital for ensuring that any repairs are accurately performed to restore vehicle functionality. Understanding the intricacies of diagnostic procedures aids technicians in isolating the problem. Once all troubleshooting steps are completed, it's imperative to perform final repair verification to assure that the issues associated with DTC P24BF are resolved effectively. The first action is to retest the evap systems to confirm proper operation and closure of the canister changeover valve. Next, clear the DTC from the PCM to reset the system and monitor for any new errors that may arise. Following this, assess the engine performance under various driving conditions to ensure it functions smoothly without symptoms like rough idling or poor fuel efficiency. Finally, check for any recurring symptoms that might signal lingering issues, as continuous monitoring is essential to guarantee comprehensive repairs and prevent future complications. Preventive maintenance is crucial for ensuring the longevity and proper functioning of the evaporative emission control system, making it particularly relevant for the canister changeover valve and associated components. Regular inspections should include the evap system, focusing on potential wear, corrosion, or damage that may accumulate over time. It's also vital to routinely check wiring and connectors for integrity, as fraying or corrosion can lead to serious electrical problems like those indicated by DTC P24BF. Ensuring proper grounding is another essential step, as poor electrical connections can disrupt signals and lead to erroneous error codes. Additionally, keeping components clean and free from debris helps to maintain optimum function and prevents obstructions in the system. In conclusion, understanding the implications of DTC P24BF is fundamental for both technicians and vehicle owners. By following the detailed troubleshooting steps provided, any anomalies can be precisely pinpointed, leading to accurate repairs and enhanced vehicle operation. Each step serves as a crucial checkpoint in diagnosing issues with the canister changeover valve and related components. Effective communication regarding symptoms, careful inspections, and thorough testing facilitate a streamlined repair process. Additionally, regular preventive maintenance not only mitigates the risk of future issues, but enhances overall performance, ensuring that the Honda CR-V remains reliable and efficient in the long run. Please like and subscribe to the channel. See you next time.